What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus 701 certification exams. So let's get into it. In this video, you're going to learn about public key infrastructure, encryption, and transport and communication security. All right, so let's talk about public key infrastructure, also known as PKI. So this section is going to highlight important public key infrastructure concepts, starting with key management. From there, we're going to dive into certificate authorities, intermediate CAs, and registration authorities. And the discussion of PKI continues with the coverage of certificate revocation lists, certificate attributes, online certificate status protocols, and certificate signing requests. All right, so let's go ahead and talk about a public key. So a key management system is used for managing cryptographic keys throughout their life cycle. And public key infrastructure is a key management system of hardware and software, policies and procedures, and people. It is used to create, distribute, manage, store, and revoke digital certificates. If you have connected to a secure website in the past, you have used PKI. However, PKI can be used for other things as well, such as secure email transmission and secure connections to remote computers and remote networks. And PKI basically is all encompassing. It includes users, client computers, servers, services, and most of all, encryption. However, do not confuse PKI with public key encryption. Though they are related, PKI is a way of accomplishing public key encryption, but not all public key encryption schemes are PKI. All right, next let's talk about private and public keys. So PKI creates asymmetric key pairs, each with a public key and a private key. The private key is kept secret, whereas the public key can be distributed. In some PKI implementations, a trusted third party, which is also known as an escrow agent, securely stores private keys in what is called a key escrow. And this is done to ensure that under specific circumstances, such as when a private key is lost or a legal requirement applies, the key can be retrieved and used by authorized entities. While key escrow serves as a safety net, it also raises concerns about the potential misuse or unauthorized access to sensitive keys. If the key pair is generated at a server, it is considered to be centralized and the public key is distributed as needed. If the key pair is generated at a local computer, it is considered to be decentralized and the keys are not distributed. Instead, they are used by that local system. And an example of public key usage would be a certificate obtained by a web browser during an encrypted session with an e-commerce website. An example of a private key usage would be a user needing to encrypt the digital signature of a private email. The difference is the level of confidentiality. The public key certificate obtained by the web browser is public. It might be obtained by thousands of individuals, and the private key used to encrypt the email is not to be shared with anyone. So in a nutshell, public key infrastructures are set up in such a way as to bind public keys with user identities. This is usually done with certificates distributed by a certificate authority. Less commonly, it is done by means of what is called a root of trust. All right, next let's talk about encryption. So encryption is the process of converting information into a coded format that is unreadable by unauthorized users. Encryption plays a crucial role in information security, serving as a critical defense against unauthorized data access. And several kinds and levels of encryption are designed to protect different types of data and meet various security needs. And this section is going to cover the wide-ranging topic of encryption, discussing its levels, its multiple uses, and various encryption techniques. All right, so let's talk about levels of encryption. So you are likely to hear discussions of levels of encryption. In the context of disk encryption, levels refers to the extent or scope at which data is transformed into a secure format. Disk encryption protects information by converting it into unreadable code that cannot be deciphered easily by unauthorized people. And disk encryption involves using disk encryption software or hardware to encrypt every bit of data that goes on a disk or volume. All right, next we have what is called full disk encryption. And this is a cryptographic method that involves applying encryption to an entire hard drive, including data, files, the operating system, and software programs. Full disk encryption places an exterior guard on the internal contents of the device. Unlike past iterations of full disk encryption, the process to encrypt hard drives has become quite simple and is supported by all the major vendors. Now, under no circumstances should you store confidential files unencrypted or at rest on your hard disk, you should use disk encryption when storing confidential or sensitive data. Disk encryption can mitigate risk of data exposure due to loss or theft of stored data, and full disk encryption can provide a blanket protection so users do not have to protect individually stored files, and it ensures that any remnants of data are secure, and such remnants can be temporary files, browser cache files, and application-specific automatic backups. All current operating systems provide disk encryption capabilities, and all major operating systems support disk encryption, so there will be no reason not to implement it. All right, next let's talk about disk partitions. So a partition is a portion of a disk that the operating system treats as a separate unit. Different partitions can be useful for running different operating systems or even creating specific storage sections for system recovery. And users can also encrypt partitions independently of other portions of the operating system. And this can be helpful when you need to store highly sensitive information alongside less sensitive data. Next, let's talk about file encryption. So files, they are containers that hold data like text, images, audio, video, or a combination of them all. File encryption adds an even deep granularity of security to data storage, allowing you to apply encryption at the file level. You might also find that encrypting specific files helps protect data in shared environments, such as in corporate computing environments. All right, next we have volume encryption. So a common way to secure large amounts of data on a disk is to encrypt the entire volume. A volume is a single accessible storage area that may include one or many physical drives. And volume encryption involves encrypting the entire volume, which might span multiple physical drives. By encrypting all the data on a specific volume, you can maintain the confidentiality of a large amount of data at once, which enhances the overall security. All right, next let's talk about securing a database. So one way to secure a database is through database encryption, which involves encrypting the database to protect sensitive information. And securing databases and applications that utilize those databases starts with 5 best practices. The first one is separate the database from the web servers, then encrypt the stored data, files, and backups of the database. Use a web application firewall, which is also known as a database firewall. And remember to keep patches current and enable security controls. You want to ensure physical security, and this is usually given, but don't leave anything to chance, and ensure that your databases are locked in cabinets. Following hardening best practices for your specific database, manage access to the database, and tightly guarded secrets. And then you want to make sure you have audit procedures and active monitoring of the database actively enabled. You also want to ensure that alerts generate tickets and receive proper attention. All right, next let's talk about record level encryption. So a record, this is a collection of related data items that are treated as a unit, such as a row in a database or a spreadsheet. And record level encryption involves securing these individual units of data, safeguarding the integrity and confidentiality of specific data entries in a larger data set. Moving on, let's talk about transport communication security. So today, more than ever before, data security is essential, whether the data is stored on a disk, moving across a network, or being actively processed. In transport communication, this refers to security measures applied to data in transit, that is, data as it moves across networks from its origin to its destination. And encryption is critical for safeguarding this data from unauthorized access and potential breaches. All right, next let's talk about encryption at rest, in transit or motion, and in processing. So what do you need to encrypt? Without a doubt, you need to encrypt data. More specifically, you need to encrypt 3 types of data. That is data at rest, data in transit or motion, and data in use or data that's being processed. Now, understanding the unique requirements for securing these data states is essential for a robust cybersecurity strategy. In this picture right here, this provides a visual representation to help you grasp these concepts more effectively. Now, data at rest is inactive data that is archived, which means it's backed up or stored with a cloud storage device. Data in transit, which is also known as data in motion. This is data that crosses a network or data that currently resides in computer memory. And data that's in use or is being processed, this can be described as actively used data undergoing constant change, such as data that's stored in databases or spreadsheets. All right, so that was my video where you learned about public key infrastructure, encryption, and transport and communication security.